Hello, our SWABAT for 11.1 is to simplify rational expressions. A rational expression is an expression of the form polynomial over polynomial. That's because if you look at the word rational, you can see ratio, which means a fraction. So instead of just having numbers like you did in elementary, you're going to have polynomial over a polynomial. An excluded value is a value of a variable for which a rational expression is undefined. So if you think about fractions are undefined whenever you have 0 in the denominator. The numerator could be anything that it wants to be, any polynomial actually, but the denominator cannot equal 0. So from your warm-up, you were told to factor each polynomial, and so if you did that, then I use a special product for number 1, and it's like a squared minus b squared equals a plus b times a minus b. So I asked myself the question, what squared gives me g squared? G squared. What squared gives me 16? 4. This is a special pattern that you're going to kind of use a lot, especially in this chapter, so memorize this if you have not. The other thing that's really crucial to this is going to be factoring using boxes. So for number 2, using a box to factor, I have 2x plus 3 and x minus 1. For number 3, using a box, I had to come up with two numbers that multiply to give me 54 and add to give me negative 21. And I had negative 18t and negative 3t. So when I factored, I have t minus 9 times 2t minus 3. So my directions are to simplify the expression if possible, and then to state excluded values. So first thing I'm going to do is go ahead and simplify. So to simplify this, I first need to factor. So factor first, pretty much always. So the numerator is already factored. It's just g plus 4. Nothing I can pull out of there. But in the denominator, you actually have factored this one on your warm-up for number 1. So we found that it was g plus 4 times g minus 4. Now what do they both have in common? They both have this whole thing in common, there and there. So what would be left? Well, if I were to take out a g plus 4 from here, I'd just have a 1 left. So my solution is going to be written as 1 over g minus 4 is left in the denominator. Now that's one solution. That's a simplified version. The other thing that they asked us to do is to state the excluded values. So your excluded values, remember, happens when the denominator equals 0. So it's excluded when it equals 0. So this cannot equal 0. You can't do it. Well, I can solve this. I can add 16 and get g squared equals 16. Then square root both sides, or cannot equal 16. And then when I take the square root, I have g cannot equal positive 4 and negative 4. Because what square gives you 16? Both positive and negative. So these are your excluded values. That's what g cannot equal to. Moving along. For your next example, again, we need to factor first. So looking at the numerator, what goes into 14 and 21? I would say 7. And then what goes into x squared and x? I can take out an x from both of those, and then I'll put my leftovers in parentheses. Notice I didn't use a box for this one because it's not in the same form as this numerator. Like, there's an x squared and there's an x, but there's not a constant. So I'm taking out a 7 from both of these, and I'm taking out an x, and what's left? Well, 7 times what gives me 14? 2. And then if I had x squared and I took off one of the x's, I still have an x left over. And then 21 divided by 7 is 3, a positive 3. And then there's no more x's here because I took it out. So this denominator, guess what? You factored that as well on your warm-up. Then we got 2x plus 3 times x minus 1 when we factored that. So looking at what they have in common, they both have a 2x plus 3. So what do I have left is just 7x over x minus 1. That's simplified form. For my excluded values, I have 2x squared plus x minus 3 cannot equal 0. So we factored that already, and we found that it was 2x plus 3 times x minus 1. That cannot equal 0. So that means 2x plus 3 cannot equal 0. And x minus 1 cannot equal 0. Putting an emphasis on that, I know, sounds weird. So when I subtract 3 to both sides, 2x cannot equal negative 3. Divide 2, x cannot equal negative 3 over 2. This one, adding 1 to both sides, x cannot equal 1. So these are your excluded values. That's a horrible box, please don't judge me. X cannot be negative 3/2 and x cannot be 1. When you're doing your excluded values, you're going to do it for the original equation, not for the simplified one. Because if I just did the simplified one, I would only have one of these two answers. Alright, so you can press pause if you'd like to and try this one on your own, or you could roll with me on this. So the numerator for this one, nothing I can do, it's just 12y to the 4th. Now these two, I don't need a box for it. I can kind of just see they both have a 6 in common, and they both have a y in common. So left over for this one is 2y, and left over for this one is 3. Now there's not a quantity that they both have in common, but I'm looking at 12 and 6 and 12 and 6, and I'm thinking they both have a 6 in common. So if I divide this by 6, I have 1. If I divide this by 6, I have 2. I'm also looking at these y's. I have y to the 4th and y to the 1st. So how many can I take away from both of them? Well, I can take 1 away from here and this is gone. And I can take 1 away from here and this is now 3. So on the top, in the numerator, I have 2y to the 3rd over, this was gone and this was gone. I still have a 2y plus 3 at the bottom. So that is simplified. The next thing, state my excluded values. Don't forget to do that. So excluded, 12y squared plus 18y cannot equal 0. Typically I would just subtract 18y or 18, but because this y is there, no can do. So I'm going to factor it, which we already did here. We know it's 6y times 2y plus 3 cannot equal 0. Then, like you did for the previous one, you're going to set each one equal to 0 or not equal to 0. 6y cannot equal to 0. 2y plus 3 cannot equal 0. I pretty much use this just like I would an equal sign, but I'm trying to emphasize the fact that it's a no can do type of situation. Dividing both sides by 6, I know that y can't equal 0. And then if I subtract 3 and then divide by 2, I know that y can also not equal negative 3 over 2. So those are your excluded values. Okay, again, got to factor. Anything and everything that we can factor, we will factor for these. So the good news is you have already factored, I just turned this into a white pen, you have already factored the denominator. You did it in the warm-up, or I did it at least. I hope you did it with me. I don't exactly remember what it was, but I know there was a 2y and a 2y, so go ahead and flip back. Check that and see what it was. Okay, sorry, I forgot and I didn't want to rework it. It was 2y minus 3 and then y minus 9, except it wasn't y, it was actually t. These are t's. My bad. And then to factor this, I can put my first term in the first box and the last term in the last box. It's negative 45. And I had two numbers that multiply to give you negative 45t squared and subtract to give you negative 4t. So I've set you up to give you a good head start for this problem. What I would like for you to do now is to finish it on your own. Thank you so much.